Good morning, everyone. So, in our last class, we did introduction to testing. We used Cairo test, wrote a smart contract, and did a and ran a test on it. So today we would continue on that, building from that knowledge so far and the smart contract we implemented that day. We dive into the more aspects of testing we didn't cover the last class. So that's what we'll be doing today. Yeah. So this was the contract we had that day, and we wrote a test to actually test if all the functions in the contract work as expected. So this was the test we wrote that day. So today we're going to progress from here and then so about this, we introduced an extra function that would be able to help users who opened accounts to close their accounts. So we should also be able to track if an account is opened or closed. Yeah, so and then in our storage now, we'd make use of the bank accounts map. So we come down here and actually make all these functions reflect the bank accounts instead of the individual state changes we had before, in state variables we had. So the first would be here. And then this particular account instance we just created for this address with this provided name, we write it into the and we don't need this tool we had here anymore. Same for down here. So we typically want to get so we get the bank account details, and then from there we pick out the balance. So this reflects the actual balance of the particular bank accounts this particular bank account struct we just created here. And then what we do is instead of this now, we pick out, okay, but instead, So from this bank account we just got, we read out the balance. And now we have the balance. But now we want to actually deposit. So the previous balance plus this new one they have. So there's this overflow and underflow error that typically happens when you exceed. So there are library functions available to help you add. And then it will tell you if there was an overflow or not. Yeah, so instead we'll just do. So we're adding it to this amount he's depositing. What this function returns is the value and if an overflow occurs. So here you would have the new balance and then if so if an overflow actually occurred, this will be true. If it didn't, this will be false. So actually want to assert or confirm that no overflow occurred when we were adding to this. So about this now, what it says is that if an overflow occurs, this won't run. If an overflow doesn't occur, this would run. But what we want is that when an overflow occurs, then this should be triggered, not the other way around. So we just negate this, and when we negate it, we are done with that. So now, this bank account now, so we don't need this anymore, but this one we had here. So what we did is, okay, so we pick out the address associated with this particular caller. So that's MSG who instantiated this deposit. And then when we get it, we get his bank balance, it's already existing balance. And then we add it to the amount he's depositing. If no overflow error occurred, then we don't panic or throw this error that overflow occurred. Then we proceed and we update his previous balance to be this new balance. And then we update the state that says, okay, this particular address now, update this to this new instance. So his new updated balance now should be reflected on state. You all understand? No, it's part of the type. Yeah.
For the mapping we created,
Yeah.
I noticed that the two mapping for the names and balance are not reflecting the accounts, the bank account stuff.
Yeah. So because we want to track all those states, that's why I'm changing it now to reflect this bank account struct. Yeah.
Now, since we can access the balance from the bank account struct, so why not just move the other things inside the struct?
Yeah, that's what I did.
Just have only one mapping.
Yeah, when I'm done with updating all the functions, then I'll remove those previous state variables.
Okay.
Yeah. Yes, if I remove them before changing this, the whole code will break. Yeah. Same for withdrawal. We actually want to get the associated bank accounts. So same here. We've updated it now to point to the bank accounts map instead of the balances map it was pointing to before. And then the same thing we check if subtraction occurs and an underflow happens, then it wasn't the desired behavior. So we report if an underflow happens or not. Yeah. No, it just like it throws the error and then reverts all state changes that happened before prior to this point. Yeah. And then transfer. So if you try to transfer more than you actually have in your account. Oh, okay. Yeah, so if you actually try to transfer more than you actually have in your accounts, then you get this error because you definitely there'll be an underflow. Maybe you had two and you try to transfer three, or maybe you had one and you try to transfer two. One minus two is minus one. Yeah. So I mean an underflow will occur. So instead of actually that minus one, it will go back to zero. And then the if an overflow or occurred or not, this flag will be true. So at this point now, if you try to do that, then you get this insufficient funds error message, and then down here, if they transfer to you like more than your accounts could actually hold. So yeah, I know the overflow would definitely occur, which maybe instead of you having 255 to 256, you now be having zero instead. Yeah, which is not a good intended behavior. So just report if an overflow occurred, and if it didn't, then yeah. So updates the balances now to point to the new balance. So this balance from new amounts would be the actual. So we don't need these previous ones anymore. Same way we don't need this anymore. So let me run down from the top again. So this is a transfer function, takes in the amount and who you want to transfer to. This particular variable gets caller address is getting who's initiating the transfer. And then we are reading his bank account details from the bank from the storage. So if it exists, if this bank account also exists as well, we are reading it from the storage. And then we are getting the actual balances. And then here now, what we do is we subtract the amount we want to transfer from who is transferring. And then we add the amount he wants to transfer to who is transferring it to. So if this balance from doesn't have more than he's trying to transfer, or there will be an error that's like insufficient, so it is not sufficient enough to make the transfer go through. And if this guy happens to have more than his accounts can hold, if this particular transfer comes in, then his own balance, his own accounts to would report that, okay, if this particular amount gets added, an overflow will occur. So maybe you should look into that. Either upgrade your account or do anything, just in a typical bank scenario, yeah. So that's what this would report. And then after we've gotten the new balances, these particular variables, we set them to be mutable because we plan to change the balance in the future. So here now we are changing the balance to reflect to these new balances, and then we are updating their storage on state. So one thing we might actually do for this is that we assert that both accounts are actually opened or registered on the platform. Yeah, so here we'll just come here and say, so if they've opened an account before, this opened field or this opened value will be pointing to true. And if it's not pointing to true, it means they've not opened an account before. So there's no point handling transactions for them if they don't actually have an account with you. Yeah.
So,
Yeah.
sorry, I have a question. Instead of this overflow, underflow, is it possible for us to just use maybe to check for to prevent negative? Just say assert account like the bank account of balance is greater than equal to amount.
Yeah, it also works that
Like
way too.
straight. And the other one I did was like define a cost out of max amount and just put the max value of 128. See, you're using 128, and just compare against that one. This is the underflow, overflow. Will this still work?
Yeah, that works too. But it's just that, like, how do I say it now? The more logic you introduce yourself, the more chances of bugs you introduce in your code. So this is part of for every type, integer type provided, they provide these methods alongside them. So there might be case where, okay, your logic is actually correct or maybe off by one or not. So I don't know if you get why I'm using this instead of writing the logic myself. Yeah. So their own logic is tested and they've tried it multiple times. So if you check like production-based token contracts, or e.g., if you look at the Open Zeppelin code base, you see that they prefer to use this overflowing add, overflowing subtract instead of actually doing it themselves.
Okay.
Yeah.
That's not.
So?
That one is more vetted and it's more trusted.
Yeah. No, no, it's a field on the bank account struct. So see it here. So we'll actually do that for this guy here. So this guy trying to deposit. Let's confirm. Same for this. Yeah, we are back here. So the last function also I asked was close account. Yeah. So because would make state change, it's a ref self, so mutable reference to the contract state. the accounts we actually want to close. I mentioned that if the person closing his accounts has balance, then he should delegate a beneficiary who he wants to give the amount he had. Yeah. So the account has been closed. The beneficiary, and if at all there was a beneficiary transaction, how much was transferred? So later on in this, we'll be testing if events were emitted. So for us to test, then we actually have to make all the fields in this event structs actually like visible in the other module. So we'll just do that using pub keyword. Yeah. Yeah, I'm listening.
Since we are already using the pub for the structs, what
Yeah.
about using the pub inside?
So if you use pub on struct, it's just the struct that's public. The fields are still kept private. So for you to make the fields public as well, you have to also add that pub keyword in front of all the fields. So you guys are close. Or do I leave it so you see like practical scenario why you should make it pub or not?
You can just leave the account created, so
Oh, okay.
someone will see the yellow familiar.
All right. Yeah. Yeah. So we actually get who's trying to close their accounts, verify they actually have an account opened with us. And if they do, we check how much they have. And if the amount they have is actually what's given out. So if it's not zero, then we give it out to the beneficiary. So that would go like this. We get the caller, then we actually check if they have a bank account. So now we have the bank accounts. We assert if it's not open, it's a non-existent account, so no point proceeding. So if we get past here, means they have a bank account registered with us. Next thing we want to check is if their balance is greater than 0. If it is, so we call the transfer method and then we'll pass in the beneficiary. This takes in amount and beneficiary. So this works, but I think for a more, how do I say it? To get the actual current time, so it could be that maybe at this block timestamp or not. In the same block, 2 transactions might happen at the same time. So one would have been that he has withdrawn everything, and another one is him still like trying to close the account and then transfer the money out. So you might find yourself double spending. Yeah, so instead of using this actual value you've loaded to state, what you could just do is maybe you do self.get balance to read the actual balance from the storage at that point. This is one because this reads direct from storage, or you actually read again from storage directly. So whichever it is you prefer at that point, yeah, you could do that. Oh? And then after this, we typically, if we've given out the money they had before, then we can proceed to closing the accounts. So their address would now be pointing to address 0. So how for every entry in a map, there's a correlating value. But it's just that if that value has been modified before, it would point to an actual value. If it hasn't been modified, it will point to 0. So what we are doing is we are just reverting everything back to 0. Yeah. So this would be so we are converting 0 to a contract address. So this gives us address 0. Another means you could do this could be through this contract address const. Although they are reporting that this particular one has been deprecated, so that's why they advise we use the try_into.unwrap. Yeah. Oh. So anyone you prefer. Well, before, at some point, this will no longer exist. If they deprecate, it means that at some point they won't be supporting it anymore. So if your code depends on this, then okay, maybe you just okay, if you've already deployed that, so but if you're building and you're still dependent on this at the point of dev, so you might find out things that were working before no longer work anymore. So you could just, so I'd advise or I'd stick to this particular one. They are in favor of more now. So yeah. Their name will just point to an empty byte array. Their balance will point to 0. Opened would be false. So we now update states to point to this closed account. And then we emit the event that so the account will close. How much the account will close? Whose account did we close? Who was his beneficiary and how much did he transfer to his beneficiary? Yeah. Close beneficiary amount. So who did we close? We closed this address, get caller, his beneficiary, and then the amounts we transferred. So this is it about it. So here we actually update this to point to dot read dot balance. So after all these changes, one way to know we didn't break anything was to check if the previous test we have or we had still runs. So so you get a transfer failed error. Okay. So it's actually pointing to who called. The account there was pointing to who received instead of from who called. So it's returning 120 instead of 730, meaning the cheat was either the cheats from this point was where the issue originated from. So at this point here, we started cheat caller with this new guy, Darren, and Darren was having around 850. From his 850 he transferred out to 120. It's supposed to be 730 now, but it's returning 120 instead. Okay, sorry, the mistake is from here. So this is supposed to be recipient, not from. Yeah. So this is another reason why testing is good. So the test pass. Yeah. So now we can go on to test the those functions individually. So if an account was created, if the right event was emitted when the account created was created, and then yeah, all deposit everything if it should panic or not. So just test them and then yeah. So typically what I was saying the other day was that every test, every test file in your test folder is treated as a separate module, and you could have multiple of those files and then have a libdot Cairo there to treat them individual as one individual module instead of multiple modules. So we could just yeah, we'll start testing from in here and then we move everything when this file starts getting um, extensive. Yeah. So our test attributes and then we are testing if the account was created successfully. So we get the contract address. And then we create the contract instance or the dispatcher. So now the values we want to pass in when we create the account. So the name and then the address. So the name of who we are creating an account for could be, and then his address would be, yeah. And then now we call the open account and we pass in the name. But typically now, the accounts that will be created most likely won't match this. How do we get it to match this? Um, yeah, start cheat code address. And then at this point now, the this particular address would match this one we have here for him. Yeah. And then to verify if this account was created successfully, we could just so we could get his balance and see it's equal to 0, else there's a balance mismatch. But this doesn't really tell us if the account was created successfully or not. Who can tell me why? Like, huh? For every entry in a map, they would always be in the default state. So if we actually put in an entirely random address here, we'd still get 0. What we should be checking is if he actually has that opened flag. Yeah, yeah. So we could just create a function that returns account details so that, yeah, we're able to pick. So we take a snapshot to the contract and then we return. So we could just revert this to the. So what this does is it gets the account details and returns the balance from the account details. So we come back here now and we check. So we assert. So if it's opened, then there's no point going to the panic message. But if it's not opened, then we get this account creation failed. So we are getting this error that member open is not visible in this context. Remember, yeah, the struct, yeah. So the error is gone now, and
So do we still need that balance check since the get account details can find anything from there?
if you
Or is
can
it just a double
test,
check?
so if if we need the balance check, so most times now maybe you know your account details, right? But you are interested in your balance, so you just dial or you check. You just want to see
I'm not
here.
interested. Yes.
Yeah, it's silver. Testers, your test should be exhaustive. Like you should not be tired of testing. Yeah, because if you overlook something, an attacker will not overlook it. So we test again and see. So now we want to test if this particular account we created, that if the function emits the event we expected it to emit. So typically, how you know if if your function emits the event here is by using the spy events from snforge std. So it helps you um, spy every event or everything that happens in your function and checks how many events did they emit. On the normal on blockchain now, you either check your logs or maybe the block explorer. Yeah. But here now, since they are giving you a blockchain environment, like for you to run or simulate your testing, they also provide you functions that help you do things like that. Yeah, so here you do. And then here you come and say the events you expected. So we expect an account created event to be emitted for every time you create an event. So the account created event and then so now here we are to populate these fields, but notice they are not giving us this public sign. So most likely like would get this not visible in this context. So name, address, balance, 0. So if we hover, they're telling us it's not visible in this context. So we go back here and also make it public as well. Then so it's telling us we are using a variable that has been moved. So we've moved this name. So here instead we clone. And then we have our expected event. So next thing we'll do is we'll do spy dot assert emitted. So it takes in what you expect is that this takes in an array of tuples. So the tuples contains the contract address and the actual event that was emitted. So if multiple events were emitted, then it goes through all of them in that array of tuples. Yeah. So this is a shorthand method for creating an array, this array macro. But then we are taking a snapshot of the array. So after we've created it, we take a snapshot and then we check now contract address, expected events. So if this event wasn't what was emitted, the test fails. Well, if it matches what was emitted, the test passes. So so it runs as expected, and we've we are almost at um, yeah, yeah. These first tests we had. Yeah, we can have it here as well. We can have a gigantic test function like this, or we could just have individual test functions. Yeah, they will go to separate files now. Or we could just have like small test functions that just test particular things. So here, I just want to be sure that an account was created successfully. Here, I just want to be sure that it emits an event. I'm echoing. So yeah, I just want to be sure that the event was emitted. So if I feel like it, I take this off and I don't really care. Like it's still like it just focuses on this part where yeah, I'm checking that the event was emitted. Yeah.
Okay.
Okay. So now the taking it like splitting them into separate files. So this could be and then we'll come back here to import the module. So typically I prefer to keep module imports at the top. So mod, we have the module here. Then we come back here. For us to be able to access all those things we imported in lib.cairo, we import them using that use super. So everything here will be available here for us. All these imports and this everything visible in this assumes that every other file you create now are modules inside that lib. So if you create, I could just instead of do this, what I will just do is this. I'll just have mod, same name, but now. So this is what Cairo sees it as. So it links all of them from all the separate files they are into this single file, then compiles it. So mod or not does it just you separate them into files for easier access for you as a developer, and then it now all those laws of super, all those things. So the super of this module now is the file where it was imported in. So this our test account creation was brought into this lib here. So the super we have here now is our lib.cairo. If you create a separate module here, maybe mod Friday, and then if you use super in here now, the super would have in here would not be lib.cairo, but it will be this test account creation module.
Just be reading test account creation.
Sir?
So if you use this board Friday,
Yeah.
just use super on that. Just be reading.
Yeah, it will only read this file. The modules that are public in this particular file. That's what it will be reading.
No.
Yeah.
I noticed if we should create a new using staff view
Yeah.
app name and the rest. We don't usually have lib.cairo in our test folder.
Yeah.
So how do we do that? Let's say we don't have this lib.cairo and you want to have multiple text file like let's say text account, test events. Like test account should handle all these accounts, creation, withdraw and all of that.
Yeah.
Then test event just for the event. How do we link the files?
It's not harder than what you just saw me do. Like exactly what you saw me do. That's how you do it. Like, see, I just created. It was yesterday I created this lib.cairo, and then today I'm creating this test account creation.cairo, and then I'm moving the test from there in here. That's all you just have to do. So everything you have in here would be, yeah, would be moved in here at the point of compilation or building. And then this mod you declared here means, okay, everything I had there before, they should bring it here.
Sorry, one more.
Yeah, I'm with you.
I've seen the Cairo file, like the project, where the main lead under the source, the lead.cairo,
Yeah.
there is no code there. What they have is just all this information.
Yeah.
And then they have folders for events and all of that.
You can do the same thing here too with this particular code we have here.
Okay, let's just,
Let's do it so you see.
yes.
So first we'll just do events.cairo interface, events interface, and yeah, right. So I come back here. So I come here, use create SimpleBank. Oh, sorry, I import the interface and then SimpleBank. So the interface has gone and it's here. We build our test to see. Okay, sorry, I should import that as well there.
Do we need this Starknet contact address in database?
So we are using contract address here.
Okay.
Yeah. You said
That that one interface is not supposed to be public one interface.
uh, it's in here. I think there's a trait alongside the iSimpleBank. Actually, the error was from the tests, not from the. You said the interface is public. I want to bring this dispatcher here and then the dispatcher trait.
Like the mod interface in lit.cairo, we have imported the interface. So that I can put the interface on.
Oh. So that's it. We separate the events as well. So in here now we can just remove all the events we defined here since we're importing them. Same way, we can move out the code out of lib.cairo and everything, but so I have to focus on testing because of time. Yeah. So we've imported everything in lib.cairo for our test module inside this test deposit. Once test deposit, if you deposit emits an event, and then if it should panic, and also at this point I'll just do false test in here as well, because yeah.
But, sorry, but let's say we don't have the leaders carrying the test. This one will still work as
You'd import everything again, all those dispatchers, do all those things you did to set up, you do them again.
okay.
Because it treats every file in here as a separate module on its own. So I plan to do 4 tests in here: deposit, then check if it emits event. If it panics, so if you deposit, if you are going over your balance threshold, it will panic, and then false, meaning just random values and see how the function holds. Yeah. To deposit, you have to have an account. So we create an account and then we deposit. I should just copy this account creation part instead of rewriting that. So after opening the account, we just want to call the amount we want to deposit. So let me import this value here. Yeah. So that I'm picking a value out, that way a trait out of the bounded. So it returns either the maximum or the minimum of a given type. Yeah. So I'm depositing the highest value of U128 here. Yeah. 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 And then we check if this is the actual balance after the deposit. So so here we deposit, and if what we deposit doesn't match what we passed in, then that's if the balance doesn't reflect this value we just passed in. Then we know there was a balance mismatch. So that's the deposit wasn't working as expected. So we go back to fix. So we test and yeah. So the deposit passed. So how you filter tests for SN4Gs, you pass the like test name and picks it up. Instead of running everything, it just goes through the ones that match that particular test name. Yeah, so this time I just focus on the test that has test deposits in their name. So now it only picks the test deposit functions and tests. So we should, we've checked the deposit part. Now we're interested in the if it emits the deposit event or not. Yeah.
That's what we said. Yeah. This guy.
So the events we're expecting is the deposit made events, and then deposit made fields includes so it's saying type not found. Let's come back and check if we imported. Okay. So the amount and the address is deposited to. Then we assert emitted. So before this completes, what I does this pass or does this fail? There's no like, does it pass or does it fail? Huh?
So only existing two events, amount and address.
Huh? Yeah, that's what the event emits.
Yes.
So I'm asking, does it pass or does it fail?
Plus,
But you guys were like faint, so okay. The reason why I actually asked is that multiple events were emitted. So when you created the account, an account created event was emitted, and then when you deposited, an deposit made event was emitted. So that's what I was asking. So let's go to this should panic. So if you try to deposit when you don't have an account, it should panic. Yeah. So we skip this part where we open an account. So And then we say if we try to deposit now, it fails because it doesn't have an account created. So let's test to see that fails first.
So,
Yeah.
multiple events is emitted in one test. Is it supposed to be?
No, it's not supposed to fail. A single function can emit multiple events, like, yeah, as much as you need to notify listeners of every state change.
I think the assertion is just checking if
That particular event was emitted. So it's failing that there's a non-existent account trying to make a deposit. Yeah. So we expect this to panic. It's not a failure. It's actually what we expected. So we come back here and then we say the attributes now should panic. And then what are we expecting to be the panic message? So this is where failure would happen. If the panic message doesn't match this particular panic message we just passed. Yeah. So this should panic is part of the attributes for. Sir? Yeah, it should be the same. So you see it here, they say something like this. So if the message doesn't match what the panic message was, then that was a failure. Because your function can panic for multiple reasons. But if there's a reason you expected it to panic, then it should be for that reason only that it panicked. If it panicked for any other reason, then there was a failure other than what you expected it to be. Yeah.
So, can you come over this panel?
So in our function, right, that deposit function, we said that only people with an account on the platform should be able to deposit. So if you don't have an account, then you should not be allowed to make any deposits. So you come down here, you see it here. So you should only be allowed to deposit if you have an account. So if you don't have an account, this should fail. So we are trying to deposit, but we didn't create an account on the contract. Yeah, so we expect that it should panic that the person trying to make a deposit doesn't have an account created with us. So now when we run that function without that should panic attribute, you know, how your test is marked as failed is that if at any point in the function panicked, then that particular test is marked as failed. So this is actually a panic, but you expected it to panic. So instead of snforge to treat that as a failure, it should check that the panic message, you know, when you panic, you specify the message you want to panic with. So you should check that the panic message matches this panic message you are throwing from the function. That a non-existent account should not be allowed to make deposits. So if they match, that means the function it works as you expected. Yeah. So if the messages don't match, then it means that it panicked for an entirely different reason other than what you expected, which is something you should check or look into yourself. So you see, yeah?
When you're setting it to a maximum value, that you want.
Yeah.
Can you just explain that?
It's just like 2 raised power 128, then minus 1. That's the maximum value of U128.
For each of those tests, that's just tests like that's like that assert contract is what you balance. That's
Yeah.
just explain that.
So I'm saying that I just deposited 128 marks. So this amount I just deposited. So now let me read my balance and see. Is it equal to the amount I deposited? So I'm getting the balance from the contract for this particular address. If it's equal, then if it's not equal, then no point. So, but in this particular function, we don't even get to this point here. From this point, the function fails and it checks if it's this panic message. So everything down here is not you don't like it doesn't get executed. But a function, a test that actually checks this is this. So see here, see where we created that max, that constant here. And then we are saying, okay, I want to deposit the maximum possible value for U128. That's 2 raised per 128, then minus 1. That's the amount I want to deposit. Remember, the name is Olowo, like someone that has money. So wants to deposit that much. Yeah, and then he deposits that much in here. And then now you want to assert his balance reflects how much he actually deposited. Yeah. Sure.
Can we test the overflow? Can we add one?
Yeah, we'll test overflow, yeah. So remember, we know this would panic, but we should be sure it panics, right? So it failed and balance overflow. So at that point where an overflow happened, instead of the person's balance now to start reading from 0 again, we prevented that from happening. Yeah. So we revert and then yeah, we'll check that our panic should actually match this. Sorry, are we together? Like, are you with us? Like, this side of the class rarely speak out. That's why I'm asking. So now, if the panic message matches this balance overflow, then the test is not marked as failed anymore. Yeah, it will pass. Already experts are testing, so
So why is the compiler not showing that line?
okay, it's language server. So the language server doesn't know how to like interpret those attributes. So if you turn off the language server, you won't see those red lines, but then you won't get those helpful suggestions it gives you. Yeah. So like if you so one thing so now I want to force deposit. So we just want to keep it like the test should just run as long as it wants until it finds edge cases where it could break. Yeah. So how you force is that instead of you actually accept input parameters. So your function now should accept an input parameter of the actual type you want to work with. So it supports every primitive type in Cairo. And then you mark the test with the fuzzer attributes. So when you have fuzzer, you could configure how long you want it to run, the seed, or you could just leave it to go based on vibes, like how the compiler likes. Should test until, yeah. But it's just that it takes time or memory, yeah. So we'll just leave it to go default first, but target just this particular test and then. So here now, instead of this amount, we just change it to the actual amount we were receiving. Yeah. So this is where we expect failure. At what point do we expect failure here? Then we wrote the deposit function together. So is there any point where we expect failure?
It's like, I think when you try to go over the
Mm,
one you want to
That's the only point of failure. Oh, okay. So if we actually added a new, you said? Oh, it didn't see it. Sorry. Let me check the name again. Force tests. Okay. Not. So if we had added a constraint whereby you can't deposit zero, only greater than zero, then if this falls like forces zero, it would fail. Yeah.
definitely want to do zero, none of that.
Yeah, there are people who just test with your contracts just for playing sake. They don't mind the gas, they don't mind anything, they just do anything they like. So that could happen when they are trying to understand how your function works, all those things. Yeah, so it tried with different, this was the seed it used. How many rounds did it go? Went for 256 rounds. So it did it 256 times and at no point did it fail, yeah.
That particular test,
Yeah.
So
256 times.
that will prevent zero deposit and this user can try to deposit
Zero, yeah.
So what error are we going to get?
So you get the error message you specified when you assert that they shouldn't,
So the test
yeah.
is going to come out as failed test or
Yeah, it will come out as failed when you didn't expect that panic. But now, if you expect the panic for that particular one and others that would have passed without panicking were to pass, then because they didn't panic, that test will be marked as failed.
can we also declare a test like this user test now with a should panic message
Yeah,
just for the scenarios of let's say deposit zero and max.
we can actually force this one we have up here, this overflow. Yeah. So this our overflow now, we are depositing max, right?
Yes.
So we'll just take in add the fuzzer now,
Oh.
right? And then taking an extra amount. But the amounts could be zero also. So the amount we get plus one. So here now,
Instead of what is the amount?
and then we target this particular test.
Let's stop that. Let's keep making us look at this, but there's no.
So like everything we've been doing so far, you guys are following how we started, how we migrated from the previous states to, and then how we are using force now. So for every run, it was successful. Yeah. So I don't. We've seen cheat codes. We've seen fuzzing. We've seen tests, spy events. Yeah.
One more thing that I like also is the ownership.
Yeah. So
The owner,
when we would have done that, but like when you guys are doing components, they introduce the owner stuff. You get. So you now have like the ownable component, and then you're able to test functions that are only restricted to owner. To focus on like testing fully. So if I divert to introducing components now, would not cover testing. Because now,
also do the owner now we have to move into components.
so the reason why it's advisable you use Open Zeppelin ownable components is that you the ownership, access control you would write, if it has not been audited.
Yes.
So somebody else might find ways to break it or like, yeah. But then Open Zeppelin, their own ownable component has been audited and proven to like stand the battles of time. So it's advisable you use components for things like that. Yeah. Yeah.
So I wanted to ask, how does our contract handle cases? So in Solidity, we have the personal cover function, cases where tokens are sent to that address. In this case, how do we handle it?
So we are about to move into that now. Yeah. So that we'll be able to cover fork testing. So we do this transfer money, actually check the blockchain state at that point in time, and then if it matches. Yeah.
Let's see, how do we assess timestamp
In test.
not in Solidity we just do block.timestamp.
Yeah.
So how do we achieve that?
It's actually a cheat as well. Something gets. Let me just go to that cheat code references. So you'd see all the cheat codes you want here, like C block timestamp, C block number. So from here you get anything you need about block.
Wow.
Yeah.